Okay, so I should have probably typed a topic 4 on this worksheet, and I don't know if I just forgot, got ahead of myself. I don't know. So this is technically going to be part 2 of topic 3. Topic 3 would have been way too long if I tried to do just one video, so it's going to be split into 2. I wish I had a topic 4, but here we are. Wrong pen. Okay, so for example 7, the directions say find the exact value of the following. That shouldn't surprise you because the whole point in this section is finding the exact value of things that maybe it feels like we shouldn't be able to get exact values for. Okay, so what we have is cosine of inverse sine of 2/3 plus inverse tangent of -3/4. So let's talk about a few things. So please recall for inverse trig functions, we have an input value that is a ratio and an output value that is an angle. So when we evaluate these inverse trig functions, the result is some angle. So inverse sine of 2/3 is really just some angle. So let's go ahead and just call it alpha. And then inverse tangent of -3/4 is going to be some other angle. Let's call it beta. So we can already rewrite this as cosine alpha plus beta for now. Okay, we'll deal with the sine or the inverse sine and inverse tangent in just a bit. Now, in case you have forgotten, let's go ahead and fill in our formula. If we have cosine of alpha plus beta, it is cosine alpha times cosine beta minus sine alpha sine beta. Okay, so that's the formula that we ultimately need to use, but we have to find values for cosine alpha, cosine beta, sine alpha, and sine beta. Okay, let's go in a little uphill. Let me fix it. Okay, so we're going to build triangles based on the fact that sine is going to have some ratio of 2/3. So sine of some angle alpha has to have a ratio of 2/3 because remember, if we have sine or inverse sine of 2/3, it equals some angle alpha. Therefore, sine of some angle alpha has to have a ratio of 2/3. Same thing for tangent. But when we have inverse tangent of -3/4 equaling some angle beta, that tells me that tangent of beta has to have a ratio of -3/4, but we do have a condition. You have to remember when we built these trig functions initially, we had to initially start by restricting the domain on the standard trig function so that we could build the inverse. That restricted domain became the restricted range for the inverse trig functions. So we just have to make sure that theta is between -pi/2 and pi/2 for sine, not theta, alpha. And we need to make sure that beta is between -pi/2 and pi/2. You just have to be careful. The range restrictions are almost the same for sine and tangent, except tangent, you can't include the endpoints. Okay? So what does this mean? This means inverse sine and inverse tangent have to be angles in quadrant 1 or 4. Okay? Because from -pi/2, if you can envision the unit circle, -pi/2 is down here. +pi/2 is up here. We have to be somewhere in this region. Okay, so this is Q1, this is Q4. Okay, so let's build these triangles. So let's talk about alpha. Okay, well, alpha, we're dealing with sine, let's see, inverse sine of 2/3. That's going to be our angle alpha. So we know that sine is positive. We have a positive ratio here. Sine is positive in quadrant 1. Okay, so let's build the triangle in quadrant 1. So we're going to get just some arbitrary angle, okay? We're going to name the angle alpha, okay? And then we need to label the sides. We know the ratio for sine of alpha is going to be 2/3. Well, sine is opposite over hypotenuse, so we need the side opposite alpha to be 2, and then the hypotenuse needs to be 3. And then we just use the Pythagorean theorem to find this missing side along the x-axis, okay? So we would get c squared equals a squared plus b squared. C is the hypotenuse, so that's going to be 3 squared. A squared is what we're missing. B is 2, so B squared is going to be 2 squared. So let's see, I get 9 equals A squared plus 4. I want to get the A alone, so I want to start by just subtracting 4 from both sides. That's going to give me A squared equals 5, which tells me that A is square root 5. And that is going to be positive because we're in quadrant 1, so along the x-axis, that's positive root 5. So cosine of alpha is going to be root 5 over 3. Remember, it's adjacent over hypotenuse. And sine of alpha, we already know to be 2 over 3. Okay? So that is the alpha angle. It's cosine and sine of that. Okay? Now we need to repeat the whole process for beta. Okay, well, for beta, we're looking at inverse tangent of -3/4. Well, tangent is negative in quadrant 4, so we need to build our angle in quadrant 4. Okay, so we're going to build it like so. So there's my angle beta. Now I know tangent of beta is -3 over 4, so that's going to be opposite over adjacent. And because this is the positive x-axis and this is the negative y-axis, I need my negative to be on the y-axis. So that's going to be my side opposite, and then my adjacent side is going to be 4. And then we do the same thing. We want to use the Pythagorean theorem to find the length of the hypotenuse. So c squared equals a squared plus b squared. So c squared is going to be 4 squared plus -3 squared. Well, 4 squared is 16, -3 squared is 9. So c squared is 25, which makes c equal to just 5. Okay. Now, we want to find sine and cosine of beta. So sine of beta is opposite over hypotenuse, so that's going to be -3/5. And cosine of beta is the adjacent side over the hypotenuse, so 4/5. So now these values for sine and cosine of alpha and beta, we need to just plug those into this sum of cosine, or sum of angles formula for cosine, okay? Oops, I need to scoot this. Alrighty, so let's get to it. So we know that cosine of alpha is root 5 over 3, and then cosine of beta is 4 over 5. We need to subtract sine of alpha, which is 2/3, times sine of beta, which is -3/5. And to simplify, let's multiply each half of this. So root 5 times 4 is just 4 root 5, and it's going to be over 15. -2 times -3 is +6 over 15. And if I clean it up just a little bit more, I get root 5 plus 6 over 15. And there you have it. So it was a bit of work for sure because we had to incorporate those ideas of inverse trig functions, but we're solid mathematicians. We can do this, okay? So something like example 7 is not particularly difficult, but it's a little tedious. There's a lot that we had to do here, okay? Now, it's example 8 that's a little bit wacky. All right, so example 8 says solve the equation, and I originally wasn't even going to give you this, but then I noticed a couple of other people assign a problem like this, so I figured I might as well do like the others do, you know, when in Rome. All right, so we have sine of some angle theta minus cosine of that same angle theta equals -√2, and we want to solve it on the interval 0 to 2 pi. Okay, well, what in the world do? We don't have a value for theta, so we can't do anything there. There's no way to combine like terms here. There's not an identity that relates just plain old sine and cosine. So we're kind of like, well, shoot, what do we do? Well, we know we're in a section where we're dealing with sum and difference formulas for sine and cosine. And because we very specifically have a sine and a cosine, let's see if we can build something that looks like one of those formulas. So just really quickly, let's kind of go through the formulas, okay? So we know that if we have cosine of alpha plus beta, it equals cosine alpha times cosine beta minus sine alpha sine beta. If I have cosine of alpha minus beta, it's cosine alpha cosine beta plus sine alpha sine beta. Okay, and then on to sine, if we have sine of alpha plus beta, that equals sine alpha cosine beta plus cosine alpha sine beta. And then if we have sine of alpha minus beta, we get sine alpha cosine beta minus cosine alpha sine beta. Okay, so those are our four formulas. And what we're going to try to do is we're going to try to create something that is the same like template, the same format as one of these formulas. Okay, now what we're going to do first is going to make life a bit easier for us later. Okay, so we have that cosine theta minus that sine theta minus cosine theta equals negative root 2. Let's see if we can get this equal to 1 or negative 1. It'll just make life easier for us down the road. So let's go ahead and divide all three terms by root 2. Okay. And when I do this, I'm going to write these in a very, very particular format. Okay. So we know that we're looking for something that's going to match one of these formulas. And notice these formulas all have four parts. We have the first part, the second part, and then we have a plus or a minus. Then we have a third part and a fourth part. So we have four parts to all of these. So when we rewrite this formula here, we want to write it kind of like there's that part there, those four parts, okay? So let's see what we can do here. I'm going to go ahead and simplify sine of theta. I'm going to think of it as sine of theta times 1 over root 2. Okay, it's the same thing. If I had sine of theta divided by root 2, it's the same thing as sine of theta times 1 over root 2. I'm then going to subtract cosine of theta times 1 over root 2, and that's all going to equal negative 1. Okay, now my very next step is going to be to rationalize this mess here. So I know that if I have 1 over root 2, I need to rationalize it. So I multiply by some weird form of 1, which ends up being root 2 over root 2. And I get root 2 or root 2 over root 2. That's my weird form of 1. And when I multiply, I get root 2 over 2. So I'm going to rewrite this again as sine of theta times root 2 over 2 minus cosine of theta times root 2 over 2. And that equals negative 1. We're going to like that root 2 over 2 in just a bit. Okay? So how can we rewrite this? We want to see if we can get things to match one of these formulas. And right off the bat, I can get rid of two of my formulas. I can get rid of this one, and I can get rid of this one because that middle operation is addition, but we need subtraction. Okay? So we can go ahead and eliminate the list by half, okay? So let's build here. We have sine of theta times cosine of theta. So those are going to end up being kind of the same thing. So let's say that ends up being, did I call it alpha? I did. So let's say that is, let me go back to black. Let's say this is sine of alpha times root 2 over 2 minus cosine alpha times root 2 over 2, okay? And that equals negative 1. Now, we know that multiplication is commutative, so we can move the sine alpha, the root 2 over 2, the cosine alpha, the root 2 over 2. We can move them really any way we want, okay? And what I notice here is I have a sine on the left side, and so that kind of automatically takes this one out because on the left we have the cosine in the cosine of alpha plus beta formula, and I have a sine, so that matches this one right here, okay? So if this is sine of alpha, this is technically cosine of beta, all right? And if this is cosine alpha, that leaves this one being sine of beta, okay? So let's think about how this is going to work, okay? So we've got our sine of alpha, we've got our cosine alpha. We technically have our cosine beta and our sine beta, we just have the actual ratios, okay? And then what we need to do is think about how we can like rewrite this formula, okay? So I'm going to rewrite it as sine of alpha cosine of beta minus, and then I'm going to do cosine alpha sine of beta. And then instead of saying equals negative 1, I'm going to write out what the formula actually equals. The formula is actually equal to sine of alpha minus beta. And then you've done something similar to this depending on how your instructor taught when you did partial fraction decomposition. We had to kind of line up like terms. So we need to do that now, okay? So we're going to line up things that are sort of the same. So we have the sine of alpha and the cosine alpha. There's not a whole lot we can do with that, okay? So over here we have sine of alpha and we have cosine of alpha, but we don't know what alpha equals, okay? No big deal. We'll come back to that. Now, we also have this cosine beta, but we know it has to be equal to root 2 over 2. So we know that cosine of beta is root 2 over 2. We also know that sine of beta is equal to root 2 over 2. I forgot my beta, hold tight. Let me erase that. So sine of beta equals root 2 over 2. So let's think about it. If we're on a unit circle, okay, we draw this angle right here, and it has a ratio of root 2 over 2 for sine and cosine. What angle gives us that ratio? Well, the angle is pi over 4. So we now know that beta has to be pi over 4 because that's the angle that gives us a cosine ratio and a sine ratio of root 2 over 2. So beta equals pi over 4. So we have some really good stuff happening here. And then the last kind of weird part, let's do it in purple. The last weird part is this -1 equaling sine of alpha minus beta. This is what we actually solve. But we needed this information up here first to kind of get to that point. We need to figure out what is alpha. We know what beta is. We don't have a clue what alpha is, though. So let's go ahead and write out the formula that we need to solve, or the equation that we need to solve. We have sine of alpha minus beta. We know it equals -1. Okay. Well, the question I would ask is, when does sine equal -1? Well, if we're on, again, that doggone unit circle, okay, we need to know, when do we have an x-coordinate of -1? Or not an x-coordinate, a y-coordinate. So at this point right here, we have the ordered pair 0, -1. Okay, that's where sine equals -1. So what angle gives us that? Okay, so if we're going to build an angle that comes all the way over here, the angle, we're going to call it alpha. Well, we're not going to call it alpha yet. We're going to call it 3 pi over 2. Alpha we haven't figured out yet, okay? So we know that this is equal to -1 when it equals 3 pi over 2. So we're going to say, okay, 3 pi over 2 has to be equal to this stuff right here, whatever this angle is. So we know that sine has a ratio of -1 when the angle is equal to 3 pi over 2. So whatever the sine angle is, it has to equal 3 pi over 2. So that tells me 3 pi over 2 is equal to alpha minus beta. So that tells me 3 pi over 2 is equal to alpha minus pi over 4, because we know what beta equals. And now we just have a really simple solving to do. So I need to add pi over 4 to both sides. That is going to give me alpha equals 3 pi over 2 plus pi over 4. All right, I'm going to erase this right here just because I am just about out of room. And we are almost done, okay? So we have to take this right here. We have to solve for alpha. To do that, I have to add pi over 4 to both sides. That gets alpha alone. And then I have 3 pi over 2 plus pi over 4. Well, if I get common denominators, I would need to multiply top and bottom of 3 pi over 2 by 2. All right, so that gives me 6 pi over 4 plus pi over 4, which finally equals 7 pi over 4. And we were solving right here for some angle theta. We now know that angle theta is finally 7 pi over 4. Okay, so this is a tricky problem. This is not something I would test you on. It could potentially show up on a lab. It could potentially show up in a homework. Okay, so deepest apologies for giving you something so nasty. But again, when I saw that other people gave this problem, I was like, shoot, we should probably cover it. Okay, so there you have it. Again, I would never test you on something like example 8, but try to understand what's going on there. Something like example 7, it's lengthy for sure, but it's not terribly difficult. So something like example 7 is very reasonable. Example 8's a bit more cumbersome. Okay, so kudos to you with sticking through another worksheet. Super proud of you all. Keep working hard. Okay.